Hello, viewers. Here's your chemistry teacher trying to make chemistry easy and enjoyable for you people. Today, I have written the lecture on addition polymerization. Now, the concepts to understand in this topic are number one, addition polymerization of ethene to form polyethene. Number two, reduce the structure of a polymer from its monomer and vice versa. Number three, uses of polyethene. And number four, cracking of hydrocarbons. Now, let's start with addition polymerization. Now, this occurs when unsaturated monomers join together without losing any molecules or atoms. The polymer formed is called addition polymer. Now, here I have written unsaturated. Unsaturated means which have double bonds. And monomers are actually the unit molecules which are going to join together to form the larger molecule which is a polymer. A polymer is a type of long chain macromolecule that is linked together by small units called monomers. It is just like a large train which has small boxes joined together with each other. Now, polyethene, commonly known as polyethene, it is produced by the addition polymerization of ethene monomers at high temperature and pressure and a suitable catalyst. Thousands of alkene molecules join together to form a polymer. Now I've written the equation ethene. On the arrow I have written the condition, that is high temperature and pressure. Under it I have written catalyst and it forms a polyethene. Now here I have written the formulas. There are 3 molecules of ethene I have shown, and again on the arrow at high temperature, pressure and catalyst I have joined all the 3 molecules of ethene, and you can see that the double bond has been broken and now we have all the single bonds. If you look at the center one, you can see that ethene molecule, it is joined to 2 other molecules on right and left side. So each monomer will join the 2 other monomers on its sides. So double bond breaks. Each monomer forms a single bond with 2 other monomers. This is called polyethene. Now why we are saying ethene? Because our monomer are all ethene molecules. Now the general equation, N, I have written the bracket ethene molecule. N means it's a larger number, high temperature and pressure catalyst. And now you can see, and here you have to clearly see that I have broken the double bond, and on the sides there are single bonds on which I have drawn the brackets, and outside the bracket there is n number, which means that all the n number of ethene molecules are joined together. Then we have the structure formula, that is, you can see I have opened the bonds, and on the right side I have written the monomer. And the repeat unit is the one which is going to be repeated again and again. So in your questions which are going to be asked, they will be asking you that write down the formula of the monomer. So you can see in the second equation on the right side it is the monomer, and the repeat unit, sometimes they ask you to find out the repeat unit, and under it I have written the repeat unit. Formula of polymer can be written by using its repeat unit. Now here this is also be asked, that is the write down the formula of the repeat unit. So this is the formula of the repeat unit. The letter N represents a large number of ethene molecules which can vary between 10,000 and 30,000. Sometimes it can go to 50,000 also. Now there are two types of polyethenes, LDPE and HDPE. LDPE means low density of polyethene and H means high density of polyethene. Depending on reaction conditions of polymerization of ethene can produce LDPE and HDPE. Now the physical properties, as the name suggests, low density polyethene, so it has low density. HDPE has high density. LDPE are soft, HDPE are hard. LDPE are flexible, HDPE are stiff. LDPE floats on water, whereas HDPE sinks in water. LDPE softens on heating, whereas the HDPE retains their shape on heating. The bonds do not break. Now, on the right side, we have LDPE on burning gives normal flame, whereas HDPE gives sooty flame. LDPE, when burns, it smells like a burning candle, whereas HDPE, when burns, it gives a waxy smell. LDPE can be easily cut, HDPE cannot be cut. So the uses, now we come to the uses. LDPE used for making plastic bags and cling films, whereas high density polyethene is used for garbage container and water pipes. There are many other uses also, but these are some of them which I have written. So the preparation of HDPE, if ethene is bubbled with a hydrocarbon into a hydrocarbon solvent with a complex catalyst at 100 degrees centigrade and at atmosphere pressure, HDPE is formed. Whereas LDPE, if ethene is heated to 180 degrees centigrade at extremely high pressures of around 1000 atm, atm stands for atmosphere, with little oxygen present and as initiator, LDPE is formed. Now I come to preparation of alkenes. Number one is cracking of petroleum. Cracking is the breaking down of long chain hydrocarbons into smaller molecules. For example, hexane, when it is cracked or broken down, it changes to butane and ethene. I have given you the equation. C6H14 forms C4H10 plus C2H4, and then I have drawn its full structure formula, and in this after two carbon atoms there is a crack and it has broken down into two molecules. You can see that there is, when a larger alkane is broken down, it breaks down into smaller alkanes and alkenes, sometimes also hydrogen. A catalyst may be used to speed up cracking. This process is called catalytic cracking. Now we come to the laboratory preparation, that is in school, of alkenes by cracking of hydrocarbons. Petroleum vapor is passed over a heated, broken porous pot. Now porous pot, as I have written in the bracket, contains aluminium oxide Al2O3 and silicon dioxide SiO2, which act as catalyst. Now products formed are mixtures of alkanes and alkenes, especially ethene. You can see the diagram. There is one boiling tube. In boiling tube, you can see glass soaked in liquid petroleum, then broken porous spot in the center. Now here we are going to apply heat, and you can see the delivery tube. On the right side, you can see the trough of water and a tube inserted over it, and you can see the bubbles formed on the bubble formed are mixtures of alkanes and alkenes. Now, industrially, alkenes or cracking is done by a process known as industrial cracking. In industries, cracking is done by, in bracket I have written, in plants called crackers. So cracking is done by passing the petroleum fractions containing long chain alkanes over a catalyst of aluminium oxide and silicon dioxide at high temperature, about 600 degrees centigrade, to form various products. For example, long chain alkanes are broken down into mixture of short chain alkanes plus mixture of short chain alkanes and hydrogen gas. Now C8H38 forms C2H4 alkene, which is ethene over here, and an alkane C6H14, or C8H38 C18H38 forms C8H18 16. Now this is again an alkene plus C10H20, another alkene, plus hydrogen molecule. Industrially, hydrogen is produced by cracking of alkanes. Now, importance of cracking. It converts long hydrocarbons in petroleum into smaller, more useful molecules. Now, there is a question on cracking C10H22, which is the decane, produce a number of substances. Identify X, Y, and Z. I have written the equations, that is, in all the three equations, I have the um, same product. In all the three equations, I have the same molecule, that is C10H22, but the products, in first I have C2H4, second C7H16, third C10H20. So we have to identify X, Y, and Z. Remember, when we have to identify X, Y, and Z, we are going to balance the number of carbon atoms and hydrogen atoms. So in the first one, if I have C2H4, number of carbon atoms left are 8 and hydrogen left are 18. So it is C8H18 alkane. Second one, carbon 7 and H16 in the product. So the left are 3 carbons and 6 hydrogens, which is an alkene. And in the last one, we have only 2 hydrogen less. So this is Z is hydrogen gas. Now this is all about the alkenes. I hope you have understood this lecture. Thank you.